Hello there. Today we are discussing the topic of random variable and probability distribution. Now, this is a very key topic, or let us say a groundwork for a bigger topic called sampling theory. Now, sampling theory is basically that particular part of probability which is used by the survey organizations or different kind of surveys where the data is collected, and after the data is collected, it goes through all the different calculations, and then after that a particular observation is made. And this is something we all are pretty much acquainted with, particularly in the news when we hear, say, a study has found that eating chocolate can reduce the risk of cancer, say something like that. So basically, when this kind of claims are made, what they basically do, they ask a certain number of people to have chocolate, say, and then they go on doing all the medical tests on those particular people, and also they do test on some people who haven't taken chocolate every single day, and from there they conclude that the ones who have taken the chocolates, they show less chance of having the cancer, and say the ones who have not taken, they show that there are more chances. So this is just a random example. I'm pretty sure nobody has done this kind of sampling survey, and I hope they don't. Now the idea is, when they are doing this kind of survey, so how can they actually determine that having chocolate is not going to it reduces the risk of cancer? Well, they actually are not determining. What they are doing is they are calculating some probabilities, and when they do calculate some probabilities, when the probabilities are more likely in favor of the fact that the person who have the chocolate is not showing any symptoms of getting cancer, so that is basically from where they conclude the fact that this happens. So to do this kind of calculation, we need to know or need to have the idea of random variable and probability distribution. So what is the idea basically? Now we know that the particular type of activities on which we try to calculate the probability, those kind of activities are called random experiments, right? Now, what are random experiments? Random experiments are basically a particular kind of activity where we do not know what outcome is going to occur after we have performed, but we know that there are certain set of outcomes, and whatever happens, the outcome of those particular type of experiment will always be one of those outcomes from that set of outcomes. So from the random experiment we get a set of outcomes which is the prescribed set of outcomes for that particular experiment, and that is called a sample space. And the sample space, the number of outcomes the sample space has, they are called the total outcomes. So that is your total outcome. Then when we are trying to find probability, we are not exactly finding probability of the random experiment, because say for example I am tossing a coin, and if I ask you the question, what is the probability of tossing a coin, so that doesn't make sense. So what we do, we try to find probability of a specific particular part of the random experiment. Say for example, when I'm tossing a coin and I'm asking that what are the chances of getting a head or getting a tail, so we try to find probability of that particular part of the random experiment. So therefore those particular specific parts of the random experiment whose probability I am trying to find out, or basically on which I am defining the idea of probability, that particular type of those specific parts are called events. All right. And when we are defining the event, then the number of outcomes which are favorable to that particular event, they are called favorable outcomes. Well, obviously plural, because you do not know how many outcomes will be there. Now, when we are defining probability, basically when, let me call an event a E and the sample space as capital S, then probability of an event is basically the number of elements present in the event and divided by the number of elements present in the sample space. So basically that is the number of favorable outcomes divided by the total outcome. All right. So this is the basic idea of probability what we have. Now let us understand what is the idea of a random variable. So random variable, obviously it has got a direct connection with the random experiment. So let us say I am having a random experiment of rolling a die. So when I am rolling a die, what are the outcomes this random experiment can have? Basically all the 6 faces of the die. So it can turn up 1, 2, 3, 4, 5 or 6. Now random variable is basically a container. Obviously when I am talking about variables are basically containers. So these are the containers which contains the outcomes of the random experiment. So if I am talking about rolling a die, and let us say capital X is my random variable, then what are the values this capital X can have? Basically all the outcomes. So X can take the value 1, 2, 3, 4, 5, 6. All right. If let us say I'm talking about tossing a coin, then what are the values X can take? Basically your head and tail. Now let us say I am tossing 3 coins and I am keeping track of the number of heads they turn up, and I am defining the random variable as the number of heads that is turning up when I am tossing a coin. So therefore if I toss 3 coins, how many heads they can turn up? Well, what are the possible chances of numbers of heads that can turn up? Now first of all, no heads will turn up, so 0. So X can take the value 0. Only 1 head can turn up, so X can take the value 1. 2 heads can turn up, so X can take the value 2. And lastly, all the 3 turns up head, so therefore X can take the value 3. So basically random variable is nothing but it is the quantification of the random experiment. So I am marking X as the random variable which is keeping track of the different outcomes of the random experiment. Now obviously the same random experiment can have different random variable depending on how I am defining the random variable. All right. So the values the random variable can take, I denote it by small x1, small x2, small xn, like that. And the corresponding probabilities of the random variable, the values of the random variable, that is denoted by capital P within bracket capital X, that is whichever you define as the random variable, and those values are small p1, small p2, like this till small pn. All right. Now, for this probability values to become a probability distribution, the criteria is that the sum of all the probability values from I is equals to 1 to n, they must be 1. If we sum up all the probability values of all the possible values of the random variable, and if it gives you 1, then that probabilities along with the random variable values is called a probability distribution. I hope it is clear. Now let us take some example to understand how it works. Let us take this example. State whether the following is a probability distribution or not. Now, as you can see how it is written, first of all, this is how a probability distribution is written in the form of a table. Capital X is taking the values 0, 1, 2, and these are the corresponding probabilities these particular values have. Now, I told you for this particular distribution to become a probability distribution, you need to have the sum of the probabilities as 1. So let us take the first one. So in first one, the probabilities are given 0.4. So let me just sum it up. So that is 0.4 plus 0.4 plus 0.2. And I can see that it is giving you 1. So therefore, this is a probability distribution. So I can go on marking it that this is a probability distribution. Similarly, if I check the third one, I'll see that 0.3 plus 0.2 is 0.5, plus 0.4 is 0.9, plus 0.1 is 1. So this one is also a probability distribution. Now, if I check the second one, I can see 0.6 plus 0.2 is 0.8, plus 0.1 is 0.9. So which is not 1, and hence this is not a probability distribution. All right. Now let us move on to the next question. Next question says, find the probability distribution of the number of heads in 2 tosses of a coin. So now let us understand how to describe or how to define a probability, a random variable, then how to determine what values it can take, and then let us understand how to find their probabilities. So here let capital X be the random variable for the number of heads in 2 tosses of a coin. 2 tosses of a coin. All right. Now, let us understand what this random variable is keeping track of. It is keeping track of the number of heads that turn up when I am tossing 2 coins. So, what are the possible values this random variable can take? So, X can take the value 0 because it may so happen that no heads will turn up. Then the second case is only 1 head turns up. And the third case is it turns up head. Both of the times I get head. So therefore, X can take the value 0, 1 and 2. Now let us make the table here. So this is the probabilities. So this is what it is. Now let us understand, if the number of heads is 0, so when I am tossing 2 coins, how many cases are there when I am getting no heads? That is the only case when both of them turning up tail. So what is the probability of getting 2 tails? That is 1 by 4. So that is the first one. Next, what is the probability of getting one head? That is basically, there are two cases. If the first one is turning up head or the second one is turning up head. So therefore 2 by 4, so that is half. And then what is the probability of getting two heads? That is 1 out of 4, so therefore that is 1 by 4. So therefore this is the probability distribution of the number of heads in two tosses of a coin. So now I hope the idea is pretty clear. If I go on tossing say 3 coins, so this is not in the question, so I'm just elaborating. Say y is the random variable for the number of heads in 3 tosses of a coin, and p of y is keeping track of, p of y is the probability. So therefore I can be sure that y can take the value 0, it can take the value 1, it can take the value 2, and it can take the value 3. So 0 means I am getting no heads. So therefore in 3 tosses of a coin, that there is only one case where no heads will be there, so all the 3 are tails. So therefore that is 1 out of 8, right? Now next is only one head. I'll get 3 different cases, so therefore that is 3 out of 8. 2 heads, again 3 cases, so 3 out of 8. And 3 heads, that is only one case, that is 1 out of 8. So I hope the idea of defining a random variable and also the way of finding the probabilities is clear. Now obviously this is a very simple example. We will definitely over the period of time gradually move to difficult examples. Now let us move to question number 3. Question number 3 says the probability distribution of a discrete random variable is given by P of capital X equal to X, that is equals to Cx square. So now let us understand what does this mean. Capital X equals to X means capital X is the random variable and small x is the value that capital X can take, and whatever the value this random variable is taking, that small x, the probability is basically square of that multiplied by a constant c. And also it is told x can be the value 0, 1, 2, 3, 4. So that means the random variable can take the value 0, 1, 2, 3, 4. It is mentioned that c is a constant. Then find the value of c. So first let us find the probability distribution. So this is what it is given. So 0, 1, 2, 3, and this is 4. Now let us understand how to write the probability. So if x takes the value 0, so put here 0 and calculate what it is giving you. Here it comes 0 only, so write it as 0. If I put 1 here, I get only c. If I put 2 here, I get 4c. If I put 3, I get 9c. And if I put 4, I get 16c. Now it is a random variable and it is given that this is a probability distribution. So that means the sum of all the probabilities must be 1. So therefore, as it is a probability distribution, therefore 0 plus c plus 4c plus 9c plus 16c must be 1. So that gives you 4 plus 9 is 13, 13 plus 16 is 29 plus 1 is 30. So 30c is equals to 1, or c is equals to 1 upon 30. So that's the answer. Now let us move to the next problem. A random variable x has the probability distribution, it is given. For the events capital E where x is a prime number and capital F where x is less than 4, find the probability for P of E union F. Alright, so this is the question given. So let us understand what it means. So E is the event where capital X is a prime number. Now let us understand where x can be a prime number. So these are the values where x is a prime number. So therefore probability of event E, that is equals to basically probability of where x is equals to 2 plus probability where x equals to 3 plus probability where x equals to 5 plus probability where x equals to 7. Right, these are the 4 prime numbers that we have, or 4 prime values that x can take. And what are the corresponding probabilities given? So this is 0.23 plus 0.12 plus 0.20 plus 0.07. So let us find what it is. So 0.23 plus 0.12 is 0.35, 0.35 plus 0.20 is 0.55, and 0.55 plus 0.07 is 0.62. So that is the first one. Then P of F. F is given the event where x is less than 4. So x is less than 4, that means all the values that is less than 4. So P of x equals to 1 plus P of x equals to 2 plus P of x equals to 3. So these are the values. So that is 0.15 plus 0.23 plus 0.12. So 0.23 plus 0.12 is 0.35 plus 0.15 is 0.5. Right? Now, to find P of E union F, I also need what is P of E intersection F. Now, let us understand how to find E intersection F. The idea of E intersection F means something which is common to both E and F. Now, what is E? E is when x is a prime number, and what is F? When x is less than 4. So therefore, E intersection F means prime numbers less than 4. That's what it means. So it has to be a prime number. Also at the same point of time, it must be less than 4. So therefore, it will be P of x equals to 2 plus P of x equals to 3. So that is 0.23 plus 0.12, which is 0.35. Right? So therefore, now I am just short of space here. So therefore, P of E union F, that is equals to P of E plus P of F minus P of E intersection F. So that is equals to 0.62 plus 0.5 minus 0.35. So that gives you 0.5 minus 0.35 is 0.15 plus this, so that is 0.77. So that is your answer. All right, let us move to the next problem. Next question, the random variable x has following probability distribution. First is find the value of k, then find what is P of x less than 6, then P of x greater equals to 6, and then P of 0 less x less 5. So let us start one by one. Now, as it is given a probability distribution, so therefore sum of all the probabilities must be 1. So therefore as it is a probability distribution, summation pi is equals to 1. That implies 0 plus 2k plus 3k plus k plus 2k plus k square plus 7k square plus 2k square plus k must be 1. So that means what is happening here, 10k square, 2 plus 3 5 plus 1 6 plus 2 8 plus 1 9, 9k must be equals to 1, or 10k square plus 9k minus 1 equals to 0, or 10k square plus 10k minus k minus 1 is equals to 0, 10k k plus 1 minus k plus 1, that is 0. So k plus 1 into 10k minus 1 is equals to 0. So k is equals to minus 1 or 1 by 10. Now let us understand this fact that k is basically a value of probability. So probabilities can not be negative. So therefore k must be 1 by 10. All right. Once I have got k equals to 1 by 10, now let us go on finding out the values of px less than 6. So this was the first one. Now let me erase this one up to make space for doing the second one. Now remember, the value of k came out to be 1 by 10. Now once I know that the value of k came out to be 1 by 10, so what is p of x less than 6? That is p of x equals to 1 plus p of x equals to 2 plus p of x equals to 3 plus p of x equals to 4 plus p of x equals to 5. Obviously there is p of x equals to 0, but 0 is definitely not contributing here, so I haven't written it. Now p of x equals to 1 is 2k, so that is 2 by 10, plus x equals to 2 is 3k, so that is 3 by 10, plus x equals to 3 is 1 by 10, x equals to 4 is 2 by 10, and x equals to 5 is k square, so that is 1 upon 100. So to add them up, so 2 plus 3 is 5 plus 1 is 6 plus 2 8. 8 by 10 is same as 80 by 100, so this is 81 by 100. So that is the probability. Now number 3, p of x greater than equals to 6. Now let us understand this. Greater than equals to is just negative of less than, right? So that means x greater than equals to 6 and x less than 6, they are complementary events. So therefore I can write this as 1 minus p of x less than 6. Or you could have just used the normal thing, that is p of x equals to 6 and p of x equals to 7. That also you could have done. So this is 1 minus 81 by 100. So that is 19 by 100. So that is the third one. Then fourth one I can find a space here, I guess. P of 0 less x less 5, which means from between 0 and 5. So that is p of x equals to 1 plus p of x equals to 2 plus p of x equals to 3 plus p of x equals to 4. So therefore this will be 2 by 10 plus 3 by 10 plus 1 by 10 plus 2 by 10, which is 8 by 10 or 4 by 5. So that is your answer. All right, now let us move to the next portion here, and the next portion that we have is basically the mean and variance of a random variable. Now what do we mean by mean and variance of a random variable? So let us say capital X is a random variable and let capital Px be its probabilities. Now before going on discussing mean and variance of a random variable, so let me just give you another fact. So you can see that P of capital X, this can be treated as a function here. So what P is doing, P is basically a function which is defined from the set of values of x1, x2, xn. These are the values, discrete values, which the random variable is taking, and it is mapping all these values in the closed interval 0 to 1, because probabilities are basically values between 0 to 1, so it can take any values between 0 to 1. So we can just treat it like that. So P of capital X equals to xi is basically Pi. So you can treat probability here as a function. Now if the probability here it takes discrete values, then I called this capital X as a discrete random variable. And if capital X can take continuous values means what? Just not only the value 0, 1, 2 like that, but it can take any values between say 0 and 1. So it can take 0.1 also, 0.2 also, or maybe it can take negative values -1, -2, say any fraction, anything, any real number, say. Then that particular random variable will be called a continuous random variable. So our discussion will be restricted to discrete random variables and discrete values only. So we will keep ourselves here only. We are not going into the continuous part. So now once we have a probability distribution where x1, this is p1, x2, p2, x3, p3, and so on till xn, pn. So this is the complete probability distribution that we have, where obviously summation of all pi's are, that is equals to 1. Now we define something called mean, and mean is basically, this is mu, and that is basically summation of pi xi, I is equals to 1 to n. So this is mean. And then we define something called variance, which is, that is sigma square variance. So that is equals to summation I equals to 1 to n pi xi square minus mu square. So this is basically the idea of mean and variance. I hope it is clear now. So for this, what we need to do, we need to make a table. So basically till now we would have had horizontal tables. To perform this calculation, we need to make vertical tables. So we will have one column as xi, then we will have the second column as pi. These are the values which are already known. Then we'll go for finding pi xi, and then we will find another column of xi square, and then we will find pi xi square. So this will be the 5 different columns that we have to perform the calculation. We will find the sum total of this column and we will find the sum total of this column. All right. So this is basically the idea. Now, just for an example, we can do it on the previous examples which we already have. So let us trace back to one of the examples here. Say this one, let us take this one only. Now, if I would have had to find the mean and variance of this, so what we would have done, so let me just erase this whole thing up. Let me just increase the size here a little bit. So we would have made this table. So xi, pi, pixi, pixi xi squared, and then pixi square. Now let us put all the values here: 1, 2, 3, 4, 5, 6, 7, 8, and here 0.15, 0.23, 0.12, 0.10, 0.20, 0.08, 0.07, and 0.05. All right. So PIXI is pretty straightforward. So it is 0.15, 0.46, 0.36, 0.40. This is 1.00. This is 0.48. This is 0.49. And this is 0.40. So we need to find the sum here. So I'm keeping the sum for later. Let us first find what is xi square. So xi square, it is 1, 4, 9, 16, 25, 36, 49, and 64. So now we need to do some serious calculation here. So this is 0.15, this one. Now 0.23 times 4 is 0.92. Then 0.12 times 9, that is 1.08. Then 0.10 times 16, that is 1.6. 0.20 times 25, so that is 5.00. 0.08 times 36 is 2.88. Then 0.07 times 49, that is 3.43. And 0.05 times 64, that is 3.20. So now we need to do some addition here. So let us do this addition. So 0.15 plus 0.46 plus 0.36 plus 0.4 plus 1 plus 0.48 plus 0.49 plus 0.4, and that sum total is coming to be 3.74. And then PIXI squared, so that one 0.15 plus 0.92 plus 1.08 plus 1.60 plus 5 plus 2.88 plus 3.43 plus 3.2, that is coming out to be 18.26. So therefore, let us first write what is mu. Mu is basically summation of pi xi, which is 3.74. We got this answer. And then sigma square, that is summation pi xi square minus mu square. So that is 18.26 minus 3.74 whole square. So 3.74 whole square, that is 13.9876. So that minus 18.26 gives you 4.2724, so which is same as 4.27 in two decimal places. So this is your answer. Now you may be alarmed at the fact that why these values are more than 1. Now let us remember, when we are trying to find the mean and variance, we are not finding mean and variance of probability. We are finding mean and variance of the random variable. So 3.74, that is the mean. So basically the average value of the random variable is 3.74. So look here, random variable is taking the value from 1, 2, 3, 4 till 8. So the mean value is 3.74. So it is giving you the mean value of the random variable. So this is your answer. And similarly, this is the variance. All right, so we just did this calculation to make you understand how mean and variance works. Now let us take some fresh problem to solve. Let us take this problem. Now this is a very serious problem. So serious problem in the sense, now we have to first calculate the whole probability distribution, and then we have to go for finding its mean, variance, everything. Also you can find standard deviation, that is basically square root of variance, which we already know. Now let us understand what this question says. 3 balls are drawn at random from a bag without replacement from a bag containing 5 white and 4 red balls. Find the probability distribution of the number of red balls. Also find its mean and variance. So now find the probability distribution of number of red balls. So let capital X be the random variable for number of red balls. Now let us understand what values can X take. Now 3 balls are drawn at random, so that also we need to keep in mind. So when I'm picking up 3 balls at random, so that means the chances are no balls can be red, 1 can be red, 2 can be red, or 3 can be red. So X can take the values 0, it can take the value 1, it can take the value 2, or it can take the value 3. All right. Now for the probabilities, when none of the balls are red, that means there are 3 white balls that has come up. So what is the probability of none of the balls being red? So that is, in total there are 9 balls and you are picking up 3 balls. So therefore it is 5C3 by 9C3. All right. So 5C3 is basically your 5 into 4 into 3, and 9C3 is 9 into 8 into 7. So things get cancelled here. 3, 8, 4, this is 2. So therefore this is 5 by 3 2s are 6, 42. So therefore this is 5 upon 42. That is the first one. All right. Next, if one of them is a red ball, so therefore rest of the 2 will be a white ball. So therefore 5C2 times 4C1 by 9C3. So 5C2 is 5 into 4 by 2 into 4 by 9C3 is 9 into 8 into 7 by 6. So few things get cancelled here. This is 3, this is 3, then 4 and this get cancelled. You're left with 2 here. So that is 10 by 21. Now let us make space for the next calculation. P of x equals to 2. Again, 2 red balls. So 2 red balls is 5C1, 4C2 by 9C3. So 5C1 is 5, 4C2 is 4 into 3 by 2, and this is 9 into 8 into 7 by 6. So this and this cancel, this is 2. This and this cancel, this is 2, this is 3, and this 3 and this 3 cancels, and this is 4. This and this cancel, this is 2. So you are left with 5 by 14. And then the last one, P of x equals to 3. P of x equals to 3 is basically 4C3 by 9C3. So that is 4 into 3 into 2 by 9 into 8 into 7. So this cancel and this is 3. So that is 1 upon 21. All right. So now what we need to do, we need to check if we have done our calculation right and this is coming 1 or not. So summation of Pi, that is 5 by 42 plus 10 by 21 plus 5 by 14 plus 1 upon 21. Now this is something we all must do in order to ensure that we have done the correct calculation. So this is, so 20 plus 20 is 40 plus 2 is 42, and therefore this is 1. So we have done our calculations right. So this goes the first part where we have found out the probability distribution. So from here the rest of the work is pretty easy. We have to find the mean and variance, so we have to make the table. So separately we will make the table. Now mind you, I am doing it in a small space here, so therefore I have to delete things to accommodate for the next thing. You please ensure you do it in a serially, one after the other. So after you have calculated all the probabilities, write this is your probability distribution. Once you have written this, then you go for making the vertical table, that is xi, then pi xi, xi square, pi xi square. So this will be a small table because only we have few values. So this is 0, 1, 2, 3. So for 0 it is 5 by 42. For this is 10 by 21. This is 5 by 14, and this is 1 by 21. So this is 0, this is 0, this is 0. First one is all 0. Next, this is 10 by 21. This is 1. This is also 10 by 21. This is 5 by 7. And then this is 4. So this is 4 into 5 by 14. So that is 10 by 7. All right. This is 3 by 21 or 1 by 7. Let me just keep it like that only. And this is 9. So this is 9 by 21. All right. So now I need to add this. I need to add this. So 21 is the LCM. So 10 plus 15, that is 25, plus 3 is 28. So this is 28 by 21. And here 10 plus 30, which is 40, this is 49. So this is 49 by 21. All right. So what is the mean? Mean is 28 by 21, or that is 4 by 3. You can leave it like this only, or you can write 1.33. And then variance, that is summation pi xi square minus mu square, which is 49 by 21 minus 4 by 3 whole square. So that is your 16 by 9. Now I have to take some LCM here. So 21 and 9, so this is 3, 3 and 7. So that is 63. So 49 into 3, that is 7. 12 plus 2, 147. Minus 9 times 7 is 63. So 16 into 7 is 112. So therefore this answer comes around 35 by 63, which is 5 by 9. So that is your mu and sigma square, that is mean and variance. So your answer will be basically this, this and this. All right. Similarly, let us take the last problem. The last problem is 5 defective bulbs got mixed with 20 good ones. It is not possible to identify the defective bulbs by just a look, or otherwise we wouldn't have had to do this, solve this problem only, basically like our TV serials. And then find the probability distribution of the number of defective bulbs if 4 bulbs are drawn at random. Okay, so again, I am drawing 4 bulbs at random. How many defective bulbs got mixed? 5. And I am trying to find the probability distribution of the defective bulbs. So let capital X be the number of defective bulbs. So if X is the number of defective bulbs, X can take the value 0, 1, 2, 3, 4. So therefore X, Px 0, 1, 2, 3, 4. Now if 0, so let us understand what is P of X equals to 0. Now I am picking up 5 bulbs at a random. Sorry, I am picking up 4 bulbs at a random, and there are total 25 bulbs, out of which 5 are defective. So if no defective bulbs come up, so that means all the 4 bulbs are good ones. So that is 20C4 by 25C4. So that is 20 into 19 into 18 into 17 by 25 into 24 into 23 into 22. So now this looks for a bad calculation here, and if we go on doing this bad calculation, we'll see that this comes out to be some 969 by 2530. This is as bad as it can get. 969 by 2530. Then next one is one defective bulb. So if I am talking about one defective bulb, so that is 20C3 and 5C1 by 25C4. So again, another calculation, I'm just skipping that part. It is 1140 by 2530, 1140 by 2530. Next, if p of x equals to 2, that is 20C2 and 5C2 by 25C4, that comes around 380 by 2530. If 3 bulbs are bad, so that is x equals to 3, 20C1, 5C3 by 25C 25C4, and that is coming out to be 40 by 2530. And lastly, if p of x equals to 4, that is all the 4 bulbs are defective, so that is 5C4 by 25C4, and that comes around 1 by 2530. So basically this is how you have to do it. Now if they ask you further to calculate the mean and variance, so you know what to do after this. All right, so I hope this clears the topic, and I hope you have understood. If you have any doubt, do post it as a comment, or you can ask me personally. Thank you.